Hi folks, we have had a look at the installation of the Solaris 11 operating system using both live media and text install, and we installed the operating system as a virtual machine in VirtualBox. In this segment we would take a look at how to perform package administration in Solaris 11. For those who are familiar with the previous versions of Solaris, SVR4 was the packaging scheme in Solaris 10 and Solaris 9 in the previous versions of Solaris. SVR4 stands for System 5 Release 4. From Solaris 11 onwards, the packaging scheme has been changed to what we call as IPS. IPS stands for Image Packaging System. To put it plainly, the packages for the Solaris 11 operating system are located in a server. We call it as a depot server or IPS repository. When there is a need to have that package installed on our system, we contact this repository, download the package and install the package on our system. It might be tempting to relate this with the flavors of Linux that you may be familiar with, where we use either an apt repository or a yum repository to download the packages and install it on those flavors of Linux. But the key difference here is that since Solaris uses ZFS as the mandatory root file system, some of the operations like complete upgradation of the packages of the operating system turns out to be a risk-free experience. So for that we make use of the facility of the ZFS file system. So keep in mind that the image packaging system, the new way of delivering packages in Solaris 11, is so tightly integrated with the ZFS as a root file system that our upgrades are going to be risk-free. We do an upgrade of the operating system. If something goes wrong, we can always revert back to the original state with just a reboot. So let's log into the Solaris 11 machine that we have and then run a few commands to find out how we can manage packages in Solaris operating system. Let me log into the Solaris OS that I have here. We'll open a terminal. One of the advantages of the Solaris operating system is that most of the commands have been made pretty simple, in the sense that if you look at the previous versions of Solaris, you end up learning multiple commands for package administration. There used to be a PKG add to add a package, PKG rm to remove a package, PKG info to get information about the packages. Unlike the previous versions of Solaris operating system, in Solaris 11 there is only one command you need to remember, which is PKG. Rest of all are subcommands to PKG. If you want help, you can obviously get the man page of the PKG command by running man space PKG. The first command we might want to take a look at is PKG Info kernel. This is to find out the details about the version, the release of the operating system that we are running. So kernel is actually a package, and we are fetching information about a package called kernel. Now, please pay attention to this specific number that you get to see there. It actually says 175.3. This indicates the release of the operating system that we are running is 11.3. 175 was actually the build of Solaris 11, which was released to the public, which was made generally available. So 11.0 was 175.0, 11.1 was 175.1, so on and so forth, and we have the latest release in the form of 175.3, which is actually 11.3. What follows that number is what we refer to as an fMRI, what we refer to as a SRU, which is Support Repository Updates, not fMRI. That was a slip of a tongue. Apologies for that. It's called as SRU, that is Support Repository Updates. Those are the support packages that are available from Oracle only if you pay for their subscription for the operating system here. So this is one of the commands that might come in handy for you to figure out what's the kernel version you are running. There is no such thing as a patch level, unlike what we used to have in the previous versions of Solaris. Here we talk about SRUs, or the support repository updates, and the way we get that is by running the command PKG Info kernel. Let's clear the screen and okay. Now let me find out using a command which repository does my machine contact to download and install the packages. You would remember I mentioned to you that the packages are available in a repository which we call as a depot server or IPS repository, and we download the packages from the IPS repository to install on our machine. Now, what is the repository that our machine uses to download packages from the repository? We can figure that out by using a command called PKG Publisher. Now, before I go ahead, I just wanted to change the user ID from a simple user ID to the root user ID, which I am doing by using the sudo command. Certainly not a recommended option. It's always safe and secure to run as a simple user and use the pfexec or the sudo commands only when there is a real need to run administrative commands. But since this is a demonstration, and since we are going through the process of learning package administration in Solaris 11, for convenience, I have kept myself as a root user on my screen. Now, one of the commands that we might be interested in is a command called PKG Publisher, which will tell me where exactly is my machine going to download the package from. As you can see, it's a URL, and that's http://pkg.oracle.com/solaris/release. So I can always pull up a browser and then navigate to the URL http://pkg.oracle.com/solaris/release, and it will take me to the IPS repository index page. And obviously I can search for package if I want. Maybe I'll search for a package by the name AppTrace, and I will get information about that package. This long string that you get to see here is what we call as FMRI, that stands for Fault Managed Resource Identifier. Of course, this is a developer package. That's the category of package there. This is the name of the package, which is AppTrace. Followed by that would be the version number, the build number, etc. And finally, the string ends with the timestamp at which this package was published to the repository there. So I do have an option of installing this package from the browser. Obviously, in a data center setup, browser might not be an optimal choice to install the package. So we will revert back to the, we will go back to the command mode here. Now that we are very clear that there are packages available on that URL there, I could actually download and install package from there. But before I do that, I want to mention here that I could actually say PKG Info AppTrace to find out information about the package. But you can see here that it doesn't give me any information about the package called AppTrace. The reason is very simple. I don't have the AppTrace package installed on my system. So does that really mean that we will not be able to fetch information related to a package if the package is not installed on the system? That's not true. We can always query remotely. When I say remotely, it's actually querying the depot server or the IPS repository to find out information about the package. So what we could do is to run the command pkg info -r apptrace, and this is actually going to give me information related to the package from the repository there. So we can see that there is a package by the name AppTrace. You get to see the details about that package, but this time around the details are coming from the repository, because without -r, it will try to fetch the information about the package from the system, and that can happen only if the package is installed on the system. So we have the information related to the package from the repository there. There is also, of course, an option of searching for the package by using the search command. This is a command line version of the search that we performed on the browser some time back. We navigated to the package repository using the browser and we performed a search operation on the browser. This command that I'm running here is exactly the same as what I did on the browser there. Just that this time around I used a command line interface for that. And again, you can see there are 3 lines of fMRI here. which is exactly what we saw on the browser also when we searched for the package app trace. Now that we understood that there is a package by the name app trace, which is a developer package available on the PKG repository, the package repository, we could go ahead and install it. But you probably would not be interested to install the package. You might be interested to know what happens to your system when you perform the installation of that package without modifying anything on the system. What you could do is to run the command pkg install -n and app trace, which would not install the package app trace on your system, but would let you know what happens to the system if you install the app trace package. Or in other words, this is actually a dry run installation of the app trace package here. So it's fetching this from the repository, and it's going to give you some details around what will happen to your system if you attempt to install this package. It'll also tell you details like whether you need to reboot the system once the package installation is through, how much of space this package is going to consume. Those details are going to show up on the screen soon, so you can see that there. So you could see that there is one package that's going to be installed. It doesn't create a boot environment. It doesn't create a backup boot environment. So some of the details are there on your screen. But as you can see, if you really want a lot of details, then you could always use the V option there, which is actually the verbose mode, and you probably would be getting more details around what will happen if you attempt to install this app trace package. Well, that's quite a bit of details around what will happen to the system, how much space is going to be consumed, how much space is available, whether a rebuild of the boot archive would happen, etc, etc, etc. So let's clear the screen, and this time around let's perform the installation of the app trace package and see what happens. Well, there you go, the package is installed. We can verify that by running the command PKG Info app trace. Mind you, last time we run this command, it gave us a message that says use -r option to fetch information related to the package from the repository. So the package app trace is installed. And how do you remove this? Of course, the command is pkg uninstall app trace, and the package gets uninstalled. So that was a sequence of commands. We had a quick look at one, to find out from which publisher are we downloading the packages from, find out information related to a package that is not installed on the system, search for a specific package in the repository, perform a dry run installation of the package by using the -nv option, and then finally we are performing the uninstallation of the app trace. So that was fairly straightforward. One command you might want to keep in mind is the pkg command, and man pkg is going to show you all details about the various subcommands it has, plus the lot of switches that you could use to modify the behavior of the command. Very quickly, I also want to show you that if you are running on a GUI version of Solaris 11, there is also something called as a package manager, which by and large does the same thing. I mean, very clearly, this is a friend end to the pkg command that we have on Solaris 11. So we could do a search on app trace here, and you're going to get information related to this app trace from the repository, and you can see from the checkbox here that this is not installed. So I could just click on that and perform the installation by just the click of a mouse. So I do have a GUI version of the package manager. Instead of running the pkg command, I can always rely on this GUI version of the package manager if I am running a GUI based Solaris 11 operating system. Now, coming to the most important part of the discussion here, we looked at installation of the package, uninstallation of the package, etc. Now, we made a statement when we started the discussion that the most important aspect of IPS is its tight integration with the ZFS file system. Now, from Solaris 11 onwards, it's mandatory to use ZFS as a root file system. With that comes a lot of convenience because ZFS is a feature-rich file system. It has a feature called snapshot where you could take a point-in-time snapshot of the file system and you can always revert back to that snapshot in case something goes wrong with your recent file systems here. Now, there is a command called BEADM command which will show you the boot environments that exist on the system. I mean, no surprises here. There is only one boot environment and that boot environment is named Solaris by default. So I have one boot environment here. If I want to create a second boot environment, I can always do that. BEADM create, let's say Solaris-1. So it will create a second boot environment with the name Solaris-1. I can say BEADM list again and you can see there is a new boot environment by the name Solaris-1. Interestingly, the space that it consumes is almost negligible. That's the feature of the ZFS file system. It actually has pointers to the original file system there. So it's not really going to consume the same amount of space. It has pointers or it has links to the actual data in the original file system. Only the differences is what it is going to keep track of. Now the two interesting flags here, N and R. N means now. Currently, what is the active boot environment? That happens to be Solaris. Upon reboot, what will be the active boot environment? That's indicated by R. So if I run a command BEADM activate Solaris-1, I am activating the Solaris-1 boot environment, meaning I do a reboot now, it is going to come up with the Solaris-1 boot environment. So at this stage, it's not going to make any difference because both boot environments has the same data, so it hardly makes a difference, but just wanted to show you that you could change your boot environment by running the command BEADM activate. There you can see the flag is R against Solaris-1, meaning upon the reboot Solaris-1 is going to be the boot environment, but currently Solaris is a boot environment. I can go back to it. I can say BEADM activate Solaris because I want to go back to the original boot environment here. Now, all this apart, we need to find out what is the advantage. I mean, why are we discussing the boot environment in a package administration segment? The reason being, when you perform the upgrade of the Solaris operating system, you're literally downloading the packages from an IPS repository or SRU to be more specific, support repository updates. What will happen in that scenario is Solaris 11 would automatically take a snapshot of your file system, of your root file system, of course, that is the new boot environment, and these packages are going to be installed on the new boot environment that gets created. So the current and the active boot environment continues to work and that is unmodified. Once the installation of the packages are done on the new boot environment, you can always activate that upon a reboot. Now let's try and understand that using a demonstration. I'm not going to perform a full-fledged upgrade operation at this stage. The simple demonstration that follows will help us understand how a package is going to get installed on an alternate boot environment which is not active at this stage, and then later we can activate that to bring the package up. So let's run the command again, which is BEADM list to list all the boot environments. Solaris happens to be the active boot environment as is indicated by the N and R flags. So the current active boot environment is Solaris, and upon a reboot also that's going to be the active boot environment, whereas Solaris-1 is alternate boot environment. So we're going to simulate a situation where we would mount let's say the Solaris-1 under a specific mount point called /mnt. Again, if you run the BEADM list command, you can see the Solaris-1 is mounted under /mnt. I want to find out if there is a package called diffstat, and now when I run this command, it's trying to find out if this package is installed in our Solaris boot environment, because that's the active boot environment. I could do the same thing by running the command PKG -R/mnt info diffstat. Now, what this will do is to figure out if we can get information related to the package diffstat from Solaris-1, because that's what is mounted under the /mnt directory. Again, there is no package called diffstat under the /mnt directory, meaning in Solaris-1. So let's go ahead and install that in the alternate boot environment, which is Solaris-1. So let's say pkg minus capital R/mnt install. We would like to install the package diffstat. And this of course is going to get installed in the alternate boot environment, which is Solaris-1. So the active boot environment is untouched by any of these changes. There is absolutely not going to be a package called diffstat in the active boot environment, which is Solaris. We will see that soon once we are through with the installation of the diffstat package under Solaris-1 boot environment. So it's all going through fine. It's fetching the package from pkg.oracle.com Solaris/release. That's the default package repository there. So it's done. Now when I run the command PKG Info diffstat, this is going to look for the diffstat package in the active boot environment. No prices for guessing there. The active boot environment does not have a diffstat package. On the other hand, we run the same command on the other hand, we run the same command on the /mnt directory. It's pkg minus r/mnt info diffstat. You can see that the package diffstat is available in the Solaris-1 boot environment. We could confirm this one last time by activating the boot environment Solaris-1. So let's run the badm list command. You could see Solaris-1 is going to be the active boot environment when we reboot the system. So let's go for a reboot, and you could think of this as very similar to the upgrade procedure. Once the upgrade is done on the alternate boot environment, we do a reboot of the system, which is when the alternate boot environment is going to be activated with the upgraded OS image. You can see that the grub is now highlighted on the Solaris-1. We will proceed with that. Let's log in and then we will do a check on. Remember, this is the Solaris-1 boot environment. That's what we activated, and it has the diffstat package that we installed. We could go ahead and verify that. First, let's find out what is the active boot environment. Again, no surprise there, it's Solaris-1. Now we say pkg info diffstat. You can see that the package is installed in the Solaris-1 version. So that concludes our basic discussion on the package administration in Solaris 11. Of course, there is more to it. You probably would have understood the basic commands to find information related to the package, search for a package, perform a dry run installation using -nv option, install the package, uninstall the package, then work on the boot environment. So that makes it clear how well the image packaging repository is integrated tightly with the ZFS file system that's used as the boot environment. So that's the advantage here. We could perform an upgrade operation without worrying too much about what happens if something goes wrong. There is always an option of reverting back to the original state in case if something goes wrong. So please explore more, because there are more subcommands with the PKG command. There are many number of options that you could use. Maybe in a later segment we would be discussing about how to set up your own package repository rather than relying on pkg.oracle.com/Solaris/release. So that's of course a story for another day, but I hope you have managed to understand the basics of the image packaging system in Solaris 11 operating system. I want to thank you so much for watching this episode and hope to see you soon.